In this video, we will see the classification of crystalline solids. Now students, you know what is a crystalline solid. Crystalline solid is a homogeneous solid in which the constituent particles, by particles I mean atoms, ions or molecules, they are arranged in a definite repeating pattern, They are called as crystalline solids. Now crystalline solids, they are further classified in two types or the forms. The first is isomorphous. First form of crystalline solid is the isomorphous form. Iso here means same and morphous means the form. Two or more substances having the same crystal structure. So we will call them as isomorphous form. So I can write here that two or more substances having the same crystal structure they are called as isomorphous. Iso means same and morphous means form. So having same crystal structures, they are called as isomorphs, and the property or the phenomena is called isomorphism. The property is called isomorphism. The constituent atoms of isomorphous substances, they have the same atomic ratio. Now students, what is the meaning of atomic ratio? By that I mean when you write the molecular formula and the chemical properties of the substance, if they are similar, that means they are isomorphous to each other. So to know this better, let us see what is the meaning of atomic ratio. For that, let us see some of the examples of isomorphous substances. If I write sodium fluoride and I write magnesium oxide. Now what I will see here, this is sodium here. So this is 1:1. This is called as atomic ratios. If I see here magnesium 1:, oxygen, that is oxide form, is 1. So it is in the ratio 1:1. You can see that this ratio, atomic ratio, is same and therefore they are isomorphic to each other. Let us take one more example, that is sodium nitrate and I will take calcium carbonate. Here if I see sodium, that is 1:1:3. Same I see here 1:1:3. So I will call them isomorphs. Some more isomorphic substances we can have, like potassium sulfate, that is K2SO4. And instead sulfur, now I will take selenium, so it will be K2SeO4. If I see the ratio, this is 2:1:4 and same here 2:1:4. So I can call them isomorphous substances. Let us take one more. So, or you can do for this, this is Cr2O3 and let us have one more, that is Fe2O3. So whether they are isomorphic in nature, whether they are isomorphic to each other. So you please find out the ratio and give me the answer in the comment box for this. This is the first form, that same substances, that is substances, two or more substances having the same crystal structure and having the same atomic ratios. We call them as isomorphous substances, or this is the isomorphic form. Some substances, they are not isomorphous even though they have the same atomic ratio, similar molecular formula and similar chemical properties. This is only and only because they have different crystal structures. And so we don't say that they are isomorphous. The best example for this type is sodium chloride, that is NaCl and KCl. If I see the atomic ratio here, this is 1:1 and same 1:1 here. Although according to atomic ratios, they have the same ratios, but they are not isomorphs because they have different crystal structure. So they have different crystal structure, and therefore they are not isomorphs. Right, students? Now, this is the first form, that is isomorphous form. What is the second form of crystalline solid is polymorphous. Now, what is the meaning of poly? Poly means many. Morphous means forms. Means what can be the definition? If I say it is poly, means a single substance that crystallizes in two or more than two forms. Now, why this crystallization takes place in two or more than two forms is only because of crystallization under different conditions. So, it is very much similar to the allotropic forms. So, I can say they are allotropic type or forms. So, what is the definition for polymorphic? I can say that a single substance that crystallizes in two or more forms under different conditions. I can call it as crystallization conditions. Right, students? And they are also called as allotropic forms. What can be the example here? The best example what you can have here is the crystalline forms of carbon allotropes, and that is diamond, graphite, you have fullerene. They are the polymorphic forms of carbon. Next, you can have rhombic sulfur, and monoclinic sulfur. They are also the allotropes of sulfur. You can have silicon dioxide, calcium carbonate. They also have the allotropic forms. So how I can classify crystalline solids? Crystalline solids are mainly classified in two types, that is isomorphous and polymorphous. Isomorphous having two or substances having the same crystal structure, same atomic radii. What I call them as the atomic ratios. Atomic ratios, they are same. Please comment your answer for this, whether they are isomorphic to each other. Now next what we have is, it is not necessary that if the atomic ratios they are same, they must be isomorphic. Example what we have seen is NaCl and KCl, because they have different crystal structures, so we don't call them isomorphs. Next form is polymorphous form or the allotropic forms. They are very, very similar to allotropes, and that is substances. They just have two or more than two forms because the crystallization conditions, they are different. So students, please like my video and share it. Please subscribe my channel if you want to get more videos. Thank you, students.